This video is going to present segment and angle bisectors. A segment bisector is a line, segment, or ray that passes through the midpoint of a line segment. So we have three examples here. In each example we have a segment AC, 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 and for each one of these the point B is the midpoint. And to remember from our previous lesson, midpoint is the point that divides a segment into two congruent segments. So the midpoint is directly halfway between the two endpoints. So the segment bisector is a line, in this case in the first example, a line segment in the second example, or a ray in this third example that passes through the midpoint of a line segment. So in each case, it passes through the midpoint B. Therefore, a segment bisector divides a segment into two congruent parts. And what do we mean by two congruent parts? We mean that the measure of AB is equal to the measure of BC in all of these cases. That's what those tick marks indicate. That this segment or this line or this ray is dividing the segment into two congruent parts. So here's an example. A segment bisector, again, is a line, segment, or ray that passes through the midpoint of a line segment. So in this case, we have segment EF, and I'm going to state that point G is the midpoint of segment EF. So the question down here then is name the segment bisector. So the segment bisector is what is dividing, what line, segment, or ray is going through. Oh, that's not what I meant to do. I need a different color. Sorry about that. What ray, line, or segment is going through this segment BF at its midpoint? And the answer to that would be ray, and we'll have to give it a name, GR. And I didn't name that part, I meant to, so that's point R. So, ray, GR, is the segment bisector for segment EF. Why? Because G is the midpoint, therefore it divides EF into two congruent parts. What is the measure of EF? So if I told you that right here segment EG was 8 centimeters, what is the measure of EF? Well, if that is 8 centimeters, then GF is 8 centimeters, so 8 plus 8 would be 16 centimeters. Next is a perpendicular bisector. Let me just go back 2 slides for a second. If you notice here that all of these segment bisectors, they go through the midpoint on some kind of angle. They're not straight. When you have a particular instance where that segment bisector, whether it be a line, a segment, or a ray, when it goes through the midpoint, if it forms a right angle, we have a more specific type of bisector, and it's called a perpendicular bisector. So the perpendicular bisector is a line, segment, or ray that passes through the midpoint, but when it does, it forms a right angle. So that's what that square indicates, right angle, 90 degrees. So that's a perpendicular bisector. And then the last one is our angle bisector. An angle bisector is a ray, line, segment, or line that divides an angle into two congruent angles. So much like the segment bisector that divides a segment into two congruent segments, the angle bisector divides the angle into two congruent angles. And again, congruent means same measure. Now, in all of these cases, the angle bisector is DB. And in all these cases, the angle bisector is a ray. So if we have segment ABC that's part of line AC, this ray, BD, actually I should rename that, sorry. BD, sorry. always name the ray starting with the end point, bisects that angle, that straight angle, into two congruent parts. This one, angle ABC, again, ray BD is dividing that one angle. These are two adjacent angles, two smaller angles that form the larger angle, but now it is dividing it in such a way that they're both congruent angles. You can have a ray that divides an angle into two parts, and it doesn't have to be congruent, but if they are congruent, then it's called an angle bisector. Over here, again, BD, angle bisector, and over here, BD, angle bisector. Now you'll notice that these are marked with arcs and tick marks. You don't always have to use the tick marks. Sometimes you'll just have the same number of arcs, and I'll show you that in another slide. So sometimes we use arcs with tick marks, and sometimes we just use arcs, but they indicate congruent angles. So here's an example. I have angle MNO, and then I have ray PN. And based on the fact that this is drawn with these two arcs, see how there's no tick marks, there's two arcs? It's telling me that these two angles are congruent. So when we go to name the angle bisector, it's going to be ray NP. Because ray NP is what is dividing the angle into two congruent angles. So that's the angle bisector. Now what is the measure of MNO? If I put in here, so if I said right here that MNP is 40 degrees, and I want to know what MNO is, that means this one is also 40 degrees because they're congruent, because this is the angle bisector, divides into congruent parts. So if this one's 40, then this one's 40. We add them together, and the larger angle is going to be 80 degrees. And just on this last screen, just to show you, sometimes, again, they'll just be arcs and no tick marks. That's another way to indicate congruent. And then for this one, just to show you, this segment, AE, or you could say AC, either one of those segments is the angle bisector for BAD. And another example on this one for angle bisector, we have BD, or just ED, these are segments, is the angle bisector for ADC. So a segment divides an angle into two congruent angles. A segment divides an angle into two congruent angles.